Today I'm going to discuss with you on the topic viscosity. In this present topic, I would like to cover introduction to viscosity, definition, viscosity coefficient, equation related to the viscosity coefficient, and the units of the expressing viscosity coefficient in CCS and SI system. Viscosity, introduction. What is this viscosity? The viscosity is a property of a liquid. You know, different liquids have a different fluidity or a different flowing efficiency or a capacities. And you might observe also different liquids have a different thickness or different liquids have a different densities. So you observe the water with the castor oil. The thickness of the castor oil and the thickness of the water is totally different. And you allow them to flow, a drop of a water and a drop of a castor oil. They have to flow in a different rate with the same amount. Why this difference? So this all being explained with the property called as the viscosity. What is this viscosity? A definition. What the viscosity defines itself is, it may be defined as the force of friction between two layers of a liquid moving fast one another with a different velocities. I will repeat this definition. It may be defined as the force of friction between two layers of a liquid moving past one another with the different velocities. The two important terms here is the force of friction and the different velocities. For what? For a liquid having two layers. A liquid having a different layers. In between the two layers, when they are moving with the different velocities, while moving with the different velocities, there is a force of friction will be appeared. This force of friction between two layers of a liquid moving past one another with the different velocities is called as a viscosity. As a result of this, due to this force of friction, you know, in physics, whenever there is two objects in contact with each other or an object contact with a surface, there is always an existence of a friction. So due to this friction, there is a resistance to flow. In the same way, when there is a force of friction is happen to be in between the two layers of a moving liquid, definitely there is a resistance offered for the flow of a liquid. Therefore, viscosity, in other words, is a measure of fluid's resistance to flow. Next, I will give you the brief to define this viscosity. Take a liquid, any liquid. This liquid have a different layers like this. Okay, and like this. When this is a first layer and this is a second layer and this is a third layer. Meanwhile, I will consider the first layer moving with this velocity and the second layer may be succeeding this or following this first layer. The velocity of this first layer is this much, it's moving at a faster rate, and the second layer follows with this rate. And when these are competing between these two, there is what is called as a frictional. When these two layers are in contact with each other, this layer has to opposes the movement of this layer. Therefore, there is a force of friction. Due to this force of friction appeared in between the layer of the liquid, liquid offer a resistance to flow of a liquid. So therefore this is how the force of friction is appeared and due to which the resistance will be taking place. So this, the amount of the resistance appeared or the amount of the resistance offered due to the force can be measured in terms of viscosity coefficient. So in order to measure this viscosity coefficient, the viscosity coefficient is a constant value. You know that the coefficient term. So in order to measure this viscosity coefficient, the external force may apply to maintain the velocity gradient. What is this velocity gradient? Velocity gradient means, when I told you the layers, if consider two layers, the velocity of a first layer and velocity of a second layer may be different. So there is a difference between the two layers of the velocities. That difference in the velocities of the two layers is a velocity gradient. So in order to maintain this velocity gradient, this external force can be applied. Then the force is proportional to the area and the velocity gradient. Area means the area of the layers of the liquid, and the velocity gradient means the velocity gradient of the two layers. Now that I can show you with the equation how you can express that equation. So F is equal directly proportional to A into dV divided by dz. Okay. And what is this F? F is equal to force, A is equal to area, V is equal to velocity, and Z is equal to direction. Okay. And I can remove this proportionality constant, that is the proportionality, so that what I can write is, after removing this proportionality, I will get one constant called as eta, then A, other terms are dV by dz. Okay. Now the new term is introduced called as eta, and this F is a force you know already, and A is the area, where dV is the difference in the velocity of the layers, and Z is a direction in which they are moving. Therefore, there is a difference in the velocities of the two layers and a difference in the directions of the two layers. Therefore, this differentiation is taking dV by dz. So now this is called as viscosity coefficient. Now I can express by taking this equation. I will, and the other important thing is, why this negative? Negative sign indicates that the viscous force on the faster layer is in the opposite direction to its motion. So whatever the force is applying by the fast air layer is in the opposite direction, or is in the negative direction to the succeeding layer. Therefore, this is called as a negative sign. And the next I have to discuss is units of CGS and SI system. What is this CGS and SI system is? I will write in CGS system. In CGS system, eta is equal to F dz divided by A into dV. Just I modified the earlier equation. Eta I have taken in left hand side because I have to measure this viscosity coefficient. So F is equal to dz by dV into A. This is the modification of the earlier equation. Now F is what? F is a force. The force is always measured in terms of dynes. You know what is this dynes? Dyne is equal to 1 gram centimeter per second square, and this is called as 1 poise is equal to 1 gram per centimeter per second. How you are going to get this 1 poise from this here? So eta is equal to F is gram centimeter per second square, and dz is in terms of centimeter, and a is a centimeter square, and dv is a velocity, that is centimeter per second. So this centimeter and this centimeter gets cancelled. Gram centimeter per second square, I will just write it as dynes, and what is the remaining thing is per centimeter square per second. So this dyne per centimeter square per second can be written as a poise, or this unit can also be written as uh, a gram per centimeter per second. Okay, because in dynes there is centimeter, 1 centimeter and 1 centimeter gets cancelled, and the remaining thing will be gram per centimeter per second. And the next is in SI system. In SI system, the same thing, whatever the remaining gram, wherever gram is there, you can write kg, wherever centimeter is there, you can write meter, and wherever the time is there, you can write per second square. Doesn't make a difference. And in denominator, you have meter square and meter and per second. Wherever centimeter is there, that you can replace with a meter. Wherever gram is there, that you can replace with a kg. And finally you will get kg per meter per second. So this is equal to 10 to the power of minus 1, that is equal to kg per meter per second. This is equal to 1 poise. And finally, based upon this viscosity coefficient, we can express the fluidity. What is fluidity? This fluidity term is called as phi, and this phi is mathematically expressed as 1 by phi. What is this 1 by phi? Phi is a viscosity coefficient. This fluidity is the capacity of the flow of the liquid is inversely proportional to this viscosity coefficient. Viscosity coefficient, that is eta, is higher and phi should be lower, or eta is lesser, phi should be greater. Means that the eta, that is viscosity coefficient, that is a resistance, is greater, definitely the flowing capacity will be lesser. Eta is greater, then definitely flowing capacity will be lesser. If eta is lesser, flowing, that is a fluidity of a liquid, should be higher. Okay, and the next is I will give you some comparative values of viscosity coefficients at 20 degrees Celsius. Water, you can take the viscosity coefficient is 1.008, and acetic acid you can take is 1.229 poise, and nitrobenzene you can take the viscosity coefficient is 2.010, and C, and I will take you the one of the least value, that is ethyl ether. Among this list is 0.2333. So among these four liquids, ethyl ether is a very less viscosity coefficient. This is a very thinner liquid, and the water, nitrobenzene is having high viscosity coefficient. So this may having high lesser fluidity, and ethyl ether is having a more fluidity as compared, as we have discussed in this list. Thank you for watching this lecture.